Hey, you guys, and now we are going to talk about your brain. And we're going to discuss an assumption in this class that we're going to make that you are effectively your brain. So this presentation is maybe one way to think about how this comes into sources is to realize that your brain is the ultimate source. It is your ultimate source for reality. It is your ultimate source for interpretation, everything. And so the more that you know about it, the more knowledgeable you will be about sources, and so the better thinker you will be. So this section has 5 parts. They kind of interweave a little bit. The first one is you are your brain. The second part is we construct reality with our brains. We don't perceive reality directly by way of our brains. Instead, our brains kind of make up a model of reality. The third section is going to be you, the deceiver. In other words, I'm going to point to ways that you deceive yourself with your brain. The next thing that we'll learn is brain-based learning. In other words, how what we know about the brain affects how we should be learning. And then the very last part will be from a book called Make It Stick. And the idea behind this book is to look at the very best evidence that we have concerning how we learn. So scientists have looked into this. What is the best way to learn? And hopefully we can apply those practices in this course. So let's start off with the brain. Now, in order to learn the material of this course, we're going to assume that you're just a brain. In other words, your mind is dependent upon your brain, and we're going to do this because it will help us a little bit further down the way to talk about a distinction involving naturalism. But the general idea is here, there's theory and there's practice. And for purposes of this class, we are going to assume something for learning something on a practical level. But there may be other theories that we could address. So what does this have to do with anything? Okay. You may feel that you are not just your brain. Many people feel like in addition to their physical brain, they are also some kind of spiritual substance. And that may well be true. And there are lots of interesting philosophical arguments that take place on either side. And this is a belief that has very far-reaching implications for people. But for this class, we're going to just assume, we're going to table that discussion and say, well, let's just suppose that we're only brain, right? And that will help us learn. So one way to think about this is the brain results from evolution. And the features of the brain that were most successful as our species evolved are those that are going to still be hanging on. Now, those features are good for survival, but they're not always good for truth. You have, when you look at the brain, it's customary now to divide the brain into, well, many parts, but there are really 2 big parts. There's the new brain, this stuff up top, all those little curves, that's the neocortex. And then there's the older brain here, which is represented by both the limbic system and the reptilian brain, but this is the older brain underneath. And the old brain is kind of like a shortcut. It makes emotional shortcuts for us. The new brain is, it takes more energy. It's where you realize abstract thought. It takes longer. It's slower. Now, this figure in front of you says 20%. Your brain eats up 20% of the calories in your body. That's pretty amazing. When you consider all of the walking around that you do, all the running, all of the different parts of your body, the fact that there's one organ which sucks up 1/5 of all of your calories means that it's a drain on resources. And when you are running around and you're trying to find calories in the wild, you need to find a way to conserve those calories. Now, today we don't have this problem. My gosh, if anything, right? We have too many calories, right? Me and my little panza here, right? But our ancestors who were running around and trying to survive, for those folks, a small savings in calories might mean you could live another day. You could survive another day. And so what our brain does is it actually saves calories, it saves energy by taking little shortcuts. We'll talk about those shortcuts later, but they're often called cognitive biases. And they're not always right. The shortcuts, in fact, are often wrong, but they're good enough for most of our purposes. So let me give you an example of some of these shortcuts, and they'll demonstrate for you the second part of our presentation, which is that the brain constructs reality. So I want you to take a look at these two figures right here, these three figures. What are they? Right? They're A, B, and C. Well, now that I blow up this picture and you see beneath the B, you see 12, 13, 14, you can now see, oh, you know what? That B was actually, it could be a 13. Do you notice that the ambiguity in how it looks? Now it's clear to you, oh, that could be a B or a 13. But when you first saw ABC, it just looked like a B, right? Okay, the technical term for this is the ambiguity of the figures is suppressed in the perception. In other words, you see this as a B all at once, or you see it as a 13 all at once. Your brain doesn't register it as both. What happened was when you first saw this picture, ABC, your brain made a choice. I'm going to treat that as a B. And it didn't tell you, hey, by the way, this could also be a 13. The brain makes choices for you about how information looks and how it processes, what's a proper pattern and what's not. And the brain doesn't tell you when it's making these decisions. You just get the end result, which is, oh my gosh, it's ABC. Okay? This is important because there's a connection between how we think and how we perceive. Take a look at this Necker cube. This is a great example of this. When you look at it, initially, either this part right here is in the front, right? Or this part right here is in the front. Now you can flip between them, right? You can say, okay, this part is the front right here. Now I'm going to blink and this part's going to become the front, or this part's going to be the front, right? You can kind of flip it around a little bit. There's an ambiguity there with regard to this figure that we can trigger in you, but when you perceive it correctly as one figure or the other. You don't see both at the same time. So what that means is there are processes going on in your brain that deliver impressions to you. They deliver the way that you see the world. And it's not like you're looking at reality through a window. It doesn't really work like that. Let me give you a different example here. Okay. So let's take a peek at this, figure 5. When you look over here on the left, it looks like this gray is actually lighter than this gray. But in point of fact, these grays are the same luminescence, meaning they're equally the same color. They're equally bright. But your brain perceives this one over here on the left as being lighter than this one. And the reason why it thinks that is because it's not measuring the color of this little square. It's looking at the stuff around it and saying, okay, based on this reference, what color is this? It's doing the same thing over here, and that's why this gray looks darker. It's kind of similar to what's called adjustment. It's when you have, suppose you have this is kind of fun sometime if you want to do it. Take a cup of hot water and a cup of cold water. Put your hand in each one, and then and after about a minute, you'll find that your hand kind of adjusts to each one. Then put each of your hands in one bucket of water, and you'll find that one is hot and one is cold, even though it's the same temperature water. And it has to do with how your body was interpreting the temperature of the water before that. Well, the same thing is kind of going on here. What's the point of all this? It seems like it's going on a long time. The point is, your brain doesn't just tell you, oh, these are the same color, even though it should. And so your brain is constructing these impressions that you get. It's making decisions about what you see before you know about it. And so it's not like your brain is just some mirror to reality. It has rules that it follows, and sometimes those rules model things really well, and sometimes they don't. But the bottom line is we're not perceiving reality. Our brain is trying to construct it, right? Reality doesn't come from your senses. You build it, right? It's like a desktop, not a window. Here's another example. Suppose you walk into a room, right? So here's another way to put it. Reality doesn't just come from your senses. In other words, the data that you bring in doesn't itself just generate your reality, your worldview. Suppose you walk into a room and there's writing all over the walls, but you don't read and write that language. Well, you're going to see just a bunch of writing on the wall, right? But if you walked into that room and you could read that writing, and all of that writing was filled with hate speech that was directed toward you, right? John is a big jerk, or, right? Gabriel needs to get going on his homework or something, right? Then that would be a different experience for you. It's the same room, but what makes the difference is what's in your head, not what's out there. And it's important to realize that we color the way that we view the world and the way that we bring information in all the time. So there's not just this great pane of glass between us and reality. Instead, we're always kind of trying to build it and construct it. And how we build and construct reality has to do with our brains more so than it has to do with these features of reality that are out there, right? So let me give you another example. This one involves harmony. It's great, but I'm going to have to hum for it. Ready? Okay, I'll do this song. Da na 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 na. Okay, that is just a little hum. I hummed a bar improperly from Beethoven. It's his Ninth Symphony. It's his fourth movement. But do you notice how it kind of sounds like a song? Ba na 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 na. Okay, what makes that a pleasant harmony is not that you are listening to each note, right? It's not like it goes dun, 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 right? Instead it's dun, na, 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 na. Your mind takes all of the notes together and puts them together in your mind, and so that you can appreciate how the notes go up and down, right? So you can understand that harmony. If your brain was just perceiving reality, it would just give you a bunch of these individual notes and say, here you go. But it doesn't. Your brain does a little bit of work for you. It doesn't tell you it's doing the work, but it does the work. And you're doing this all the time. When you perceive reality, your brain is doing work. When you're thinking about something, your brain is doing work, but it's not telling you that. And so for many years, people didn't quite get, it was very hard to understand the degree to which the brain is actually building how we think of the world in very fundamental ways. So don't think of perception as a window, right? It's not like we're inside of a house and we're looking outside at reality. Instead, we're kind of looking at a desktop, right? And the desktop is built by a computer, and that computer is our brain. All right, so we did the harmony thing. Here's another example. I usually do this in class, but just think for a moment, if you've been on campus, where the parking structures are on campus. So there's one that I can think of in a number of different parking lots and how they're arranged against one another. Now, to us, this seems very natural, right, where the placement is of different buildings on campus, and this seems just an objective feature of reality. But it turns out being able to generate a map of the world and where things are located relative to one another is something that the brain actually doesn't perceive. When you're doing all this work as to where things are located in space, something as simple as this pencil, right, is here on this table, right? There's work going on right now in my parietal lobe telling me where everything is. Now, there are people for whom that segment of their brain doesn't work real well, and it's very difficult, right? It's very difficult for those folks. I'm thinking of a case from Radiolab involving a woman named Sharon. So I'm going to play this little audio for you, but the general idea is Sharon cannot make maps of the world. When she tries to do this, her brain messes up. And so she can get lost very easily, even in her own house, right? So let me see if I can get this to play.
Oh, wait, you're listening? Okay.
Here we are.
All right. Okay. All right.
You're listening to Radio Lab.
Radio Lab.
From
WNY State. Yep.
And I'm gonna add this MP3 later, you guys. We can just do that. Okay. All right. So now we're moving. Let's just stop that right there. Actually, it's a good place to stop. Okay. So now we're on to You, the Deceiver. This portion of the discussion is just going to center around features of the brain presented in a little bit different way to kind of deceive yourself. So one way to think about your brain is that it's a sponge, and it soaks up all kinds of patterns and impressions in the world. And once those patterns are in there, they can serve as an anchor, and you give an unusual amount, an inappropriate amount of credence to those patterns. So when geese are born, they will follow around the first thing that they see, right? So they will follow around. If it's a person, geese will think that a person is its mother. If the mother is there, then the geese will bond with the mother. But once that connection is made, once a baby goose thinks that a person is its parent, there's no way to unsever that connection. It is set and locked in that kind of mode. You are kind of similar to some extent in how your brain detects patterns and sees things. So this is a little clip of B.F. Skinner. I'm going to play it, and I want you guys to just take a moment to realize that he's teaching a pigeon on the basis of rewards to do a little spin. And every time this pigeon thinks that it turns, it's going to get a little spin, right? So let's just take a peek here. We won't watch much of this.
Pigeon now, and I will try to pick out some particular pattern of behavior and make it a more frequent part of the repertoire of the bird. I find this bird has been already conditioned to eat when the magazine sounds and the light flashes. Now we'll just watch its behavior a bit. It's not doing anything in particular, you see, but I'm going to try to get it to do something. Suppose I shape up the behavior of making a complete turn. What I do is simply, as I did then, to wait for some part of that behavior. There's more of it, you see. You see the effect is instantaneous. I'm waiting for it to turn counterclockwise now. And then I reinforce that movement. I wait for a more pronounced movement than that. It's got to be more than that.
So he's creating an association between a stimulus and a pattern, right? So a reward and a pattern. And eventually he convinces this bird that he needs to turn around. Now, you may say, okay, so what? Who cares? Well, this is actually super important. So during World War II, a number of American troops landed on small islands throughout the Pacific. And then they left. Many decades later, anthropologists came back to some of these islands in order to see what effect, if any, World War II had on these tribes. And what they found were cargo cults. They found people like you and me, right? They're just running a little bit different software. And what they were doing was attempting to copy the behavior of soldiers during World War II. So you see this gentleman here has USA written on his chest, and they're carrying what look like guns. And individuals on these islands would try to replicate what American soldiers were doing there. So they would build fake planes, and they would build fake runways. They would have fake parades. They'd build these fake buildings with fake desks, and even used, no joke, the ends of coconuts as headphones and pretend to talk into radios. When anthropologists asked them, hey, why are you doing this? they would say, well, if we do this, then these planes are going to fly over and drop all of this cargo for us. So that's the name, cargo cults. And what had happened was these individuals had detected a pattern between what American troops were doing on the ground and then the later arrival or the subsequent arrival of cargo planes flying by. And their brains detected this pattern, just like the pigeon did with the example from B.F. Skinner. He convinces this pigeon that you need to turn around every time you eat, right? Well, these folks made this same connection. So you can see that our brain will see a pattern sometimes, and then it will sort of fall in love with it, and it won't give up that pattern. And that's what happens here with folks with these cargo cults. Now, I mean, there's a lot of other stuff going on here, but this is just the general idea that your brain will pick out a pattern in the world and absolutely, positively convince you that it's there and it's real, even though it may not be, right? So it's not that the patterns that you see are fake. It's just that very often, even if they are not real, your brain will kind of fool you into thinking that they are real. I'm going to give you an example here involving these circles. You think I could tell the difference between a square and a circle? Okay. Which of the orange circles is bigger? This one here on the left or this one here on the right? Now, if you're just looking at these two, the way that they look is that this circle here looks smaller than this one here, which looks bigger. So the one on the right looks bigger. Why? Remember the example involving the color of the two different squares? Your brain isn't perceiving the absolute size of these circles. Your brain is saying, hey, how big is the stuff around it? Okay, it's big. Oh, so this thing must be kind of smallish. It's doing the same thing over here on the right. How big is, oh, this is bigger than these, so this looks a little bigger than this. The reason, now, if you just cut out you can't see what I'm doing, but if you just had the two circles and no gray circles around them, you could see that they were the same size. But our brain fools us into seeing a pattern that isn't there because it's not measuring the shape in total. It's measuring the shape by reference to things that are around it. It's like a little cheat, right? And it fools us into thinking that these two circles are different sizes. Now, you can try really, really hard and never, ever convince yourself that these are the same size. You objectively know that they're the same size, but they're always going to look the way that they do. And the reason why they look that way is because your brain is taking a shortcut. It doesn't matter how psyched up you are, this optical illusion will pretty much always work. And the reason why it works is your brain always takes the shortcut. So what's going on here? There are two systems. There's a system one, which is non-conscious. This is impressions, thoughts, automatic thoughts. It's your old brain right there in the bottom, right in the middle. It's kind of the reptile brain. Then there's system two, which is the neocortex, and it's on the outside. It's a lot slower. It doesn't work as often. It is very logical. It requires conscious thought and rational deliberation. Now, System 2 can override System 1, but it takes a lot of work. And so sometimes you'll hear people talk about bias, cognitive bias. This is what they're talking about. So I'm going to just take a moment here and just give a couple of slides on how bias might matter in the... Okay, before I jump ahead here and talk about why this stuff matters, so we're going to talk about why this stuff matters, but I just want to show you one example of how your brain is kind of funny. And it's related to biases and things like that. It has to do with how your brain arranges things. So what I want you to do here is name as you read these words, right, I want you to name the color of the color words. So this first one right here, the word red is written in red, right? So all you need to do is red, right? And here's one. It's green, blue, yellow. Okay, those are pretty easy. Now, I want you to try it with these color words. So name the color of the color words. So what is the color of this color word? It's yellow, white, purple, orange. Okay. What you see here is these options. What's the color of this color word? It's red. these take just a little bit longer to name the color of the color word than these do. The reason why is the concept of blue is a little bit farther away from white in your head than it is right here when you read the blue and you see it. And so what you're noticing is everything isn't perfectly arranged in your head. Some things are closer to others, and you can notice a little bit of a lag time in naming those color words. And so what people essentially do, what scientists do, psychologists do, is they take this principle and then they apply it in different areas. And they do so in a way that helps to show cases where we have biases or little warps in our brain. They're not really our fault. It's just a tendency of our minds, a tendency of our brains to work this way. So why would this matter? Why would biases matter? Well, let me talk for just a moment about my prior profession as an attorney. In 2011, there were about 1.2 million attorneys in the United States. Now, when you look here in 1980, 92% of those attorneys were male, and a significant portion of those attorneys were also white. Now, why does this matter? Well, if for some reason a group of people all share a bias, right? So suppose there are a bunch of white males and they all share some type of bias. There are so many places in our decision making and in our evaluations that can impact or be affected by bias. When you have a huge group of people and they all have that bias, you can kind of think about it as a bunch of small little things adding up to a huge effect, right? It's a bunch of small water drops. When you take them together, it's the ocean. Well, the thinking is, my gosh, maybe this is the same with implicit bias. If we have a huge combination, right? It's 1980. 92% of the lawyers are males, and that could cause a significant systematic problem if they all share the same bias. And so, there are 1,000 places in a case that bias can come into play. And so what the American Bar Association has kind of worked on is, well, what can we do about this then? Well, one, you could try to diversify the people in that group, right? So we don't need 92% of attorneys to be male. And so you see in just 2 decades that the number of females almost increases by 4-fold, and the number of males reduces. Now, it's not that men or women per se do the job of being an attorney differently. It's just that if one entire gender shares a bias or is likely to share a bias, and you have 1 million people, these things it's 1 million drops, right? And that could add up to a whole bathtub or an ocean of problems. And so the American Bar Association has worked on, what can we do to rehabilitate these biases? Now, it turns out that there's some hope. We're not forever trapped in computers that work wrong. We try to use checklists in our thinking. So as this would apply to law, a law firm would have a checklist for a case, right, or a particular type of case. And these are different points of procedure or law that they can consult at different aspects in the case just to make sure they don't miss something. Also, a way to avoid the biases is to try and be explicit about criteria that you're using to judge something ahead of time. Once your brain makes the decision, it likes it. And if the decision is wrong, we'll talk about this later, your brain kind of digs in and won't give up. And so if you can agree upon a set of criteria before you start whatever it is you're doing, and everybody buys into that criteria, that helps to alleviate some of those biases. Also, it is very helpful in an attempt to try to avoid these biases to write something instead of just talking about it off the cuff. And the thinking is that probably writing involves more of your slow system, the stuff on the outside, the new brain, than does the internal stuff, than does the old brain. And remember, the old brain is kind of instinctive and it's going to be wrong. So writing it tends to be a little bit more useful. Okay, all right, now we are on to a little bit of brain-based learning, and then lastly we'll look at make it stick. So brain-based learning. One of the most important things that I can tell you is that the brain is elastic. Perhaps you are a student who hasn't been in a classroom for a year or 10 years or 40 years. I've had a student who hadn't been in a classroom in 50 years. And I remember that student, he told me, he said, look, I'm a mechanic and I don't know anything about all this other stuff. Look, your brain will adapt and your brain will learn and it will adapt new ways of thinking. And this is absolutely across the board. I mean, unless people have some type of organic pathology, they've been in an accident, they have a head injury, your brain can learn to do new things. So I urge you not to dismiss what your brain is capable of before we get moving in the class, right? Don't worry, your brain will adjust. It may take it a week or, a month, but it'll get on board with whatever new cognitive task you're trying to push into it. There's lots of data that suggests that people will perform to their expectations. If you say you can't do a set of problems or you can't do a set of quiz questions, then you won't be able to. But if you think that you can or you say that you can, then you can. There are lots of studies like this. One I'm thinking of involves prompts that they would give to students, right? So they give students the same set of problems and they tell one set of students, look, there's no way you're going to be able to finish these problems. They're just way too difficult for you, but try. Well, statistically, most of those people didn't finish those problems, right? But then when you give the same set of problems to another group of students and you say, go ahead and try these problems, you should be able to figure them out, a statistically significant portion of those people figure that stuff out. So I don't mean to say something naive and say, oh, just think positive, it'll all work out. What I mean is your brain assesses its ability to do a task and then it will fulfill itself on the basis of that assessment. So if you say you can't do something, you will fulfill that prophecy. If you say, no, I can do this, I can get this, then you will. Our brains change with each new experience that we have. And so as a student, when you come to my classroom, your brain is like a snowflake. Nobody in the world has had your set of experiences. No one in the world has your brain. And so it's important that you realize that it is something that is unique to you. And you may see things in the curriculum or in problems or in your schoolwork that your colleagues don't see. And that's because you've had a different set of experiences in the world. And those sets of experiences have affected how your brain organizes information, how it thinks about problems, and so forth. So brains are unique, and in that sense, they're very special. Another point about brain-based learning. When you are stressed out, maybe you're concerned for your safety, it's hard to learn because when you're stressed, when you don't feel safe, the reptile brain is kind of going hardcore. It's active, and when it's active, your neocortex is not going to be able to do what it otherwise would have done. And so people who are in circumstances where there's a lot of stress, that affects the brain's ability to learn. So, it is helpful to try and learn in a safe place, whether that's a library or whatever. It's not just hokey. There's science behind it, right? You are a learning machine. We know that the machine does better in certain circumstances. End of story. Another couple of points. First off, exercise affects your brain health. Now, you don't need to go out and pump a bunch of iron and be all hardcore, but 60 minutes of walking a day or something like that has a huge impact on your brain's function. Also, good diet, right? Think of that as just a corollary of garbage in, garbage out. If you're not getting a sufficient number of fats in your diet, your brain is made of fat, bad for the brain operation. If you're not getting enough nutrition, your brain is not going to work as well. So good diet is important. And lastly, rest. We've all done it where you've done a project all day or you've studied for a test all night. You walk in, you throw it down, and then you leave it forever, right? I get that. But really and truly, your brain functions better when it has its required amount of sleep and rest. So as you're taking the course, to the extent that you can, try to get a little exercise, try to eat right, get a little rest. It'll help your learning. Okay, the old brain and the new brain. These two things are related, right? It's not like, here's a good way to put it. The new brain sits on top of the old brain. And so, because the old brain is underneath the new brain, it's still going to be primary in some circumstances. So it's not like we can scrap the whole thing and say, let's start with a new brain. No, we have to work with what's already there. So we have an older system that's evolved, right? That's our reptilian brain. And then we have another one that's on top of that. And they have to work in tandem. Okay, now we're almost to the very end of this. We're going to just talk briefly about Make It Stick. This is a book by Peter Brown, Henry Roediger, and Mark McDaniel. It's a great book. I'm going to try and summarize some of the points from it here. Not all of them. I don't know that I could. But it's really great because it's an attempt by scientists to say, gosh, science is a great thing. What can we learn from science about how we learn? And how can we put that stuff into practice? And so the first thing is, learning is effortful. It requires effort. If you are in a class and the class is fairly straightforward and easy and you're kind of breezing through it, that type of learning won't be as deep, it won't be as durable, won't last as long, and won't be as influential in your thought as will learning that requires a great deal of effort on your part. The more that you're working, the deeper that your learning goes, right? Now, if you were to just read a chapter of a book passively, that will do very little for you. It turns out that statistically speaking, that's not a very good way to learn. A good way to learn is to memorize a checklist. And then once you have that checklist at hand, your brain acclimates itself to it, and you won't miss steps and so forth. I will never just say, hey, just read the chapter, who cares, right? Here we go. I won't say just read the chapter and you'll be fine. You could read the chapter and remember nothing from it. If you're going to read the chapter, take notes. Just instead of passively reading a chapter, when you read a paragraph, just generate one sentence for that entire paragraph, right? This paragraph is talking about the brain, and it's saying that reading a chapter does nothing, so take notes, right? There you go. That would be one big chapter, one big paragraph condensed to a note. This is just a suggestion. You don't have to do this. Another point, and this is related to the very first thing that we talked about. If you say you can't, you can't, and if you can, then you can. People who tend to think of IQ as a fixed trait, like your height, right? People are 6'3", and once you're 6'3", you're not going to go down to 5'11", right? People who think that IQ is stable or a trait that's stable, like hair color or height, those people tend to avoid challenging tasks because they think that the failure in that task represents a failure of IQ. Instead, people who understand that effort and challenge are effort and challenge are parts of learning, and that failure is part of learning, those brains adapt just fine. They make the necessary changes and they move forward. So this is an important point that I'm going to quiz you on this. You'll see the question, right? You don't want to think of IQ as a stable quantity. I mean, I think to my own life. I mean, there's certainly times when I was smarter than others. Early in my life, I wasn't interested in intellectual pursuits, but later I became very interested in them. And I have a lot of colleagues who sort of, for their lives, their profession is an intellectual one. It requires their intelligence. It requires their attention. And they have a wide variety of backgrounds. And many times they've just found their calling in a class that they took, and they love that, and they develop that side of themselves, right? So try not to think of IQ as, oh gosh, it's always right here. It can change. Your brain is more like a muscle than it is anything else, and the more that you exercise it, the better off you'll be. Practice like you play. Apply what you know to new situations. The brain learns when it's got a model and then that model fails for whatever reason. So you should think of new situations that resist your analysis as an interesting and neat thing. And in some way, the whole course is like this, right? We have all of these strange paranormal stories, Spring-Heeled Jack, Bigfoot, UFOs, whatever it is, right? These are new and different situations, and we should think of them as kind of exhilarating, right? Rather than something to trash or debunk. Okay, this point is super, super, super relevant. For whatever reason, our educational system treats failure as a stain, right? And that you need to avoid failure at all costs. The problem is avoiding failure has the tendency of also avoiding trying, right? So people just avoid failure by not trying to do something. But that itself will be failure. Failure is not doing something wrong. It's failing to do something at all. Failing is going to be part of learning. And so you shouldn't think of failure to know something or failure to know how to do something as a lacking. It's necessary to acknowledge and develop your knowledge before you can be said to know how to do something or to achieve something, right? Okay, that was our overview of this particular section, You Are Your Brain. I hope it was helpful, you guys. I know this was a long one. I encourage you to look back over through the notes, and it might be able to clean up a couple of things. If you have any questions, you guys know not to hesitate to email me or tweet me, and I'd be happy to answer your questions. Thanks.